So I'm Talini, and I'm a lecturer in space engineering at the University of Bristol. I have worked in different areas. So I've worked in large companies, I've worked in small startups. I've done research in organizations and universities. So Catherine and Mrs. Kaspan suggested I kind of talk to you and kind of talk a little bit about my experience. And I hope to show that, your career is ultimately what you shape it to be. It doesn't need to fall into any predefined role if you don't want it to. And so I hope you find it interesting. So when I was very young, I had a few things that I really wanted to do. So I first want to be an archaeologist, and then I want to be a doctor all at the same time. I want to be a medical doctor. I want to do something in space, not really engineering. I wasn't too keen on engineering. I want to do something in space. And I also, when I learned about the Earth, the formation of the Earth, I really wanted to do something in geology. So, how earthquakes form and do something in that. And, but of course, you can't do all at the same time. Also, I thought. So I was always wondering, who do I want to be? And so one of the things I wanted to try and do was I really loved space, but I didn't want to be an engineer, so I didn't know how it quite fit. So my early years, I was born in Sri Lanka, and I studied all my school years were in Sri Lanka. And when I did the national curriculum, the Sri Lankan curriculum, up until GCSEs, and then I did UK GCSEs and A-levels. In Sri Lanka, when I was younger, it has changed now, but when I was younger, there were three main things that, people try to encourage you to do, either become a doctor, an engineer, or a lawyer. Those were like the three things you always hear. And going from the national to the UK curriculum, we had limited options in terms of what subjects we could study for GCSEs and A-levels. So I did the classical science. I did biology, chemistry, physics, and maths. And for GCSEs, I did geography because I loved the geology side of things. And interestingly, physics, I struggled a little bit with physics. I had to end up kind of trying different teachers to try and understand the fundamentals of some areas of physics. It wasn't my strongest subject, but as I said, I liked I was hoping to be a doctor or something to do with space. So this all fit within the classical sciences, and I was naturally interested in classical sciences. You'd also see that I don't have any history here, so archaeology kind of went away from my list of ambitions because I realized that memorizing things without a logical reason, it really was not my strength. So I didn't do history. So anyway, we have to decide, going into GCSEs and A-levels, who do you want to be? You have to tailor your subjects to try and fit that. And I decided I'll be a medical doctor because I see the medical doctors, you're always exposed to them, you know what they do. Something in space, but not an engineer, was not really a thing in Sri Lanka. And geology, I wasn't sure whether I could have a career in that. So I decided, I loved all of them equally. So I decided to be a medical doctor. Of course, as you know, it didn't turn out that way. So when it came to choosing an undergraduate degree, I then I've applied for medicine and other medical related courses, but almost overnight I decided, you know what, I like space a lot, so let's see what options are out there. So I looked at different universities in the UK, but most of them were physics related, so everything was more to be a physicist or in the physics courses. And I wasn't sure again. I wasn't sure back in Sri Lanka what my future would be if I did just physics. So I looked at engineering instead. So it was almost like a natural, logical thinking to come into engineering. It wasn't something I was looking to enter at the beginning. But my main thing was I want to do something in space. That was my main goal. So there were two universities at the time who did engineering and space in the UK. That was the University of Southampton and the University of Bath. So I selected Bath because I really liked the city and the architecture. It had a lot of culture there. So I did my undergraduate degree at the University of Bath, and the course was called Electronics with Space Science and Technology, and it was a master's course. So it was the 5 years with the placement. You do electronics engineering being the kind of the main component of it, with space science and technology in there. So that's Master of Engineering. And this was my graduating class. So when we started in my first year, I think there were about 70 or 80 students altogether, a handful of girls. And then when it came to 5 years down the line, all of us who did a placement and did the masters, it was 15 of us and 3 of us girls. Out of the 3, 2 of us are in the space industry, and the other friend, we are all friends still, is working in underwater vehicles, also in engineering. So we all enjoyed it, and it was quite a lot of fun doing different group works and projects. So for one of my projects was I didn't design the whole unmanned aerial vehicles, so UAVs or drones. But I was working on one part of it, which is the autonomous control of a drone. So if you give it go from A to B, does it figure out how to do it by itself? So that was one fun project I did during my undergraduate. So, initially I wanted to be, for years, I was thinking of being a medical doctor, but I ended up being a space engineer instead. So as part of my undergraduate, I said I did a placement. So that's quite common these days now, I think. And one of my placements, so it was 1 year long, that placement as part of the undergraduate program. And that was with a laboratory called Rutherford Appleton Labs. That's near Oxford. And I did a placement in the particle physics department, which is quite different to engineering. It's more the fundamental physics line. And I had two options. I was selected to do an engineering placement in Airbus. So Airbus is one of the largest companies who build satellites. And I turned it down, space engineering job to particle physics. And that's because in particle physics, this particular job gave me a lot of research type things I could do. I don't know whether you girls know what particle physics, what that field does. They look at how the universe was. So they look at atoms and the subparticles of the atoms, and see, what happened at the Big Bang, and also what will happen in the future. So I really like that. For me, it was a connection to space more than doing the engineering side of things. So you kind of look at the history of the universe with it, and how they do that is they have these massive particle accelerators, and they're underground. They will span tens of kilometers, and they're underground, so about a few hundred meters underground, and you've got these. They accelerate these atoms really fast, in a circular way, and they gain a lot of energy, and they smash them all together, and they see what happens, what comes out of it. So this was even though I didn't do the space engineering job, I really enjoyed this. So I don't regret it. So I had a chance to go to the US, where they had one of these facilities. This was in Chicago. And then I also got to go to Switzerland, which also has a particle accelerator. This is CERN. If anybody has heard of it, it comes into news from time to time. And it's this little circle here, which is 27 kilometers long when you take the circumference, and it crosses both the Switzerland and France underground when they for this machine. And so underground, what they have is this pipe here is where you have all these particles colliding. And this machine here is a detector. So that's what detects what happens. I don't know whether you can see, but there's a little person here just for scale. So these are massive, massive detectors. And they're a little bit like MRI scans or CT scans, where you have yourself under this whole big machine and the machine scans. So it's a little bit like that. So this was a lot of fun. In the US, in their detector here, I don't have a picture of the inside, but I helped to repair certain parts of the detector underground, which was quite a bit of fun. So after my 1-year placement, I decided every summer it would be nice to go and do another placement somewhere. So at the university, they were advertising for mostly the physics students a fellowship in Australia, and it was with the Australian Astronomical Observatory at the time. That's what it was called. And so it was not really tailored for engineering, but I thought, well, it's space. I like space stuff, so I'll try it. So I applied, and I was selected. There were 4 students from the UK, from different universities. So we were selected to go to Australia for that. Yeah, they were then rest they're promoting the 3D printers. But so these Starbucks, those little cylinders, they're actually little robots. So they would be the special material called piezoelectric material. And what happens is when you put a very strong electric field across it, it expands or contracts. So the idea was, well, if you have a little cylinder, and if you put a field on one side, it will expand. So it'll look like it's kind of crawling around the field plate, so around that mirror that you saw. So I was involved in the early stages of it. It was really nice to see that and to work on it because it was an engineering project, but in a more science-based application. So that was quite nice, and I really enjoyed that. So that was at the Australian, they used to be called Australian Astronomical Observatory. Just go there. And the fun bit of going to Australia at the time was, during the weekdays, we would work in the organization. And then during the weekends, we would go and travel around. We would see the Sydney Harbour. We'd go hiking and caving. This was in one of the highest buildings in Sydney, and they had this observation deck. So we would do all this fun stuff when we were there. With this place, what I also did was, this was a fellowship, so it was an organized program. But the year after that, I enjoyed it so much, I just contacted them and asked, can I come again? I mean, it wasn't part of the program, but can I come again for another summer placement? And they said yes. So I went back for another year, well, for 3 months, the year after. And I did another project to do with this instrumentation. So those are the placements. And then after I finished all my placements, I finished my course, undergrad course, I decided to do a PhD. And so Catherine was my supervisor for my PhD. And again, my focus was, when I was asked, what is it that you want to do? I said, I want to do a hardware project that is space related. And so Catherine was looking into space weather at the time. That's a field. And so it was decided that we would do an instrument that would go into space and measure the upper atmosphere. So went back to University of Bath for the PhD, and this was the UK's first CubeSat. It was called UCube-1. I didn't do the whole satellite. I did one of the instruments in the satellite. There were 4 instruments. And so this little pocket here is where the antenna was peeking out, the GPS antenna. So yeah, so I built that. And when we're putting something in space, there's always a reason for it, right? So we have some instrument that we want to put in space, and then we develop the satellite around that instrument. So in this case, it was space weather research. Auroras that you see, this space weather affects GPS technology and other communication technologies on Earth. And that's why you would want to look into space weather research on it and see, try to observe when a solar storm comes, so we can prepare on Earth, we can prepare for different technologies to protect them or to expect those disruptions. So that was part of my PhD. So building the satellite or the instrument of the satellite, and also looking to see once I put it up there, modeling certain things to see whether that instrument would actually work once it goes in space. Okay, so this was the instrument I built. So you can see Top Cat here. The Top Cat stands for, not the cartoon, if anybody knows of the cartoon. It's a topside ionosphere and plasmasphere computer-assisted tomography. It's a long name. But essentially, the idea is once you get the signal, it again works like an MRI or a CT scan, where you have the signal going through the upper atmosphere, and then you image it from the ground, from the receiver data. So that antenna here is what you see in this image in the satellite. And as part of the development, I was doing the electronic design, the mechanical design, the software design, functional and environmental testing, and integration into the satellite. And I didn't have, my background was not in mechanical design, for example, or environmental testing. So some of these things I learned as I was designing it. And for mechanical design, for example, I didn't know the software to do the detailed mechanical models. So it was all paper drawn, and I would go to the workshop and say, can you please build this for me? So there was a little cap, a protective cap to protect the payload from radiation. So that was my PhD and the experience I had with this. One thing to say, though, is most of it, yes, I did it myself, but you can never build any part of the satellite by yourself. It's always teamwork, right? So I had a little bit of help for the electronic design, the mechanical design, a little bit of help for environmental testing. Some of my other PhD friends who were in my group would help me with some of the testing when we had to go up onto the roof. So it was always teamwork in one form or another. So after my PhD, I went into industry. I decided I want some industry experience. I've done a little bits of research in different places. So I wanted to go into a company and see what it's like there. So this was kind of a natural progression from what I did in my PhD. It was modeling space weather for test purposes. So what I had was something called a knowledge transfer partnership. So that was transferring knowledge from university expertise into industry, into a company. I don't know whether you know of Spirent, but Catherine works quite closely with Spirent. And so this was a company where I did my knowledge transfer, the partnership with. And what we do is where you see this layer here, which says ionospheric currents. So that's where all our GPS signals get disrupted if there's a solar storm, for example. So we wanted to model that and then put that into another device so that that device can test receivers, GPS receivers on ground. So if you plug a receiver into that test machine, then you can make that receiver think it's flying in a satellite, or it's in an aircraft, or it's on a boat. So it's all done on ground. So that's what I was doing, modeling the space weather. So after I finished this, I decided, well, I still want to do something a little bit more spacey. This was great, but it was not, I was not building things for space. It was understanding what happens in space. So I decided to look around and see what other opportunities that I have. And there's this thing called the Space Studies program at the International Space University. And I decided I'll go and I'll apply for it. It's a 2-month program in the summer, and it's been held in different countries each year. So I left Spirent temporarily, and then I decided to do this space program. And that was one of the best things I did. I'll come to that soon. This particular project that I did, that was recognized for engineering excellence, and I was a finalist in one of the awards that was done for this partnership. So this was the space studies program I was referring to, and this was it was such an exciting thing to do, because you bring out different types of people, different disciplines. So we got a lot of people like lawyers and architects and everybody in one place to see what we can do in space. So yeah, I mean, we all engineers and our scientists and all our technical people, we have a lot of fun when we get together. So yes, as part of that, one of the things that I did, I was involved in, was this project where we were looking at how to provide power on the moon during the night time. So on the moon, the lunar night is 14 Earth days. So how do you provide power when there's no sun? Because we normally use solar energy to power everything in space. How do you do that? So we were involved with designing that particular project, with the power units, how we distribute on the moon to different places if you're having a base there. So that was a project I was involved in. And the teams were quite big as well, which was a challenge in a good way. We had to work together with people we don't know very well. And we built rockets. You saw in the videos, rockets going up, model rockets, and we had a little egg in it to say. And the goal was, when it comes back down to Earth, that egg couldn't have cracked. So we had our rockets going up and then coming back down. And when we open up, if it was safe, then we've been successful. So it was quite a nice experience to have. And what it also did was it opened up to me also how much opportunity there is in space. And it's not just for our standard engineers and scientists, but also geologists, medical doctors. When astronauts go into space, they rely on doctors who know about the effects that happen in space. Lawyers and architects, because now we are talking about having bases on the moon and in the future in Mars. So we need architects to develop that. We need lawyers when different people come onto these places, to the moon, or even using space in general, having satellites. We need lawyers for that. So there's actually a field called space law. The economists for space economy, the artists and the communicators who talk about space and give that message to the people, to the public. So there's a lot of, and business management as well. So there's a lot of opportunities in space. It's not only for the people who are technically, we wanted to go into the technical field. So after doing that course, I decided I want to try it a little bit out on my own. I've seen what the opportunities are. So I tried it out on my own. So I formed my own little company for a short time. And then that is where I did the SERSI mission together with Catherine at the University of Bath, Catherine and Robert. and DSTL. So this was my PhD instrument that I developed, but kind of the second version of it. So we call it TopCat 2. And it was in a 2-satellite constellation, one of the instruments in each of the satellites. Once I finished that, I also did some consulting, systems engineering consulting for a new company. It was a startup called SpaceForge. And after I did worked for SpaceForge as a consultant, I decided I actually want to join SpaceForge because they were doing some really groundbreaking stuff, really interesting things that you've never heard of in space. So then I decided to work at SpaceForge as a systems engineering lead because working in space and doing stuff in space, we've only just tapped the potential of space. The vacuum, the lack of gravity means that a lot of things can be done where we can't do on Earth because there could be defects because of gravity or because of contamination. So this is SpaceForge, and they do in-orbit manufacturing satellites. So they design satellites that can manufacture various things in orbit. So as you can see, you know, space is no longer just for standard, you know, engineering or the sciences. You know, there's agriculture there. We're talking about medical, pharmaceutical. So there's a lot of things that can be done. And when you grow up, if you still want to go into space, there'll be so many opportunities that you can just try things out. So when I was at SpaceForge, so I was a systems engineering lead. So what is systems engineering? So this is a relatively new field of engineering. Normally you have the classical ones like electronics, mechanical, thermal, that sort of thing. Systems engineering kind of tends to look at one step above. So it looks at the whole picture. Because what a lot of people realized when you do complex systems, when you build complex systems, is if the electronic engineers go away and do their thing, and the mechanical engineers go do their thing, and same thing with other different types of engineering, putting everything together can become very, very difficult. So you need systems engineers to actually look at everything, have knowledge enough to understand what the different teams are doing, and put together a product that actually works. So there's a lot of different things that systems engineers look at. So you've got risk management, requirements, defining the requirements, so very important. You have to know a little bit of hardware, the software, so all these different things, the testing. So it's very much what I did during my PhD, because I had to work on different things on the same project, but all the different elements I was working on. So this fit quite well for me. And as a systems engineer, you would know all these different types of engineering depending on what your project is. We got the kind of things that we normally know, the mechanical, electrical, software, thermal engineering, but there's also manufacturing engineering, reliability, safety, and other specialty engineering depending on what you're doing in your satellite. And also you've got these other side factors that you have to work as a systems engineer as well. So in the SpaceForge satellites that they're building, it's coming down to Earth. So you have to consider, are we going to, drop it on somebody's head, So we have to make sure you take the human factors in, you take the environmental considerations. So it's quite a wide, broad, abstract type of engineering. But it's something that I really liked because it meant that I could be involved in a lot of different things. I could see the entire system on its in its full scale. So as systems engineering lead, I was leading the satellite development for SpaceForge. So we have a saying that we say as systems engineers, we are jacks of all trades, but we are masters of some. It's not master of none, but we have to know something. So we should know some areas of expertise, but also have a general idea of other areas. So finally, this comes kind of almost the end of my talk now. After Space Forge, I worked there for 3 years, but I had the opportunity to apply for a lectureship at the University of Bristol. So very recently, I left Space Forge and then I joined the University of Bristol as a lecturer in space engineering. And the reason I did that was I really enjoyed my time at Space Forge, but I did that because this gave me to go back into research and do various things, combine different things, and do research that I like. So I mentioned earlier about space, whether I want to carry on looking into it a little bit more. Then I mentioned I like geology at the beginning. You know, I mentioned I like space. I want to do. I like geology. I wanted to be a doctor at some point, and this doing research, to me, I was able to combine various elements of all those different things. So it kind of gave me the best of both worlds or all worlds. So that's where I am now at the moment. I'm doing research and teaching at the University of Bristol. So that kind of finishes like my experience. That was how I kind of went about to where I am now. But fundamentally, there are a few things I always did that led me on this really interesting, really fun journey. And that was, I tended to always challenge the status quo. You know, just because, you know, somebody is not doing something in school as well as in, you know, at the university, of course, it's male dominated. There are a lot of boys, but only very few girls. But I didn't feel that I should not do what I like to do just because most girls don't do it. So I always tended to challenge the status quo. If I like to do something, I would see if I can do it, or and try out different things. But the key thing in this is you try out different things, but always do each of those things to the best of your ability. And that's what will show, you know, that if you have the interest and if you do it to the best of your ability, then go ahead and try whatever you like to do. Don't feel the need to follow society norms or peer pressure. You know, the society may say you have to do it something in a certain way, but you can always ask, is that the right way to do it? And if it's not, why not I do in a better way? So don't feel that you have to give in to peer pressure or society norms. And find your allies. So this could be your family, your teachers. You know, for you, you currently have Catherine and Robert and myself, who are not your direct teachers. Anybody who would be happy to encourage you to do what you like. Find those allies because they will really support you to find new ways, give you opportunities to kind of explore various things. And think out of the box. So in my case, it was the particle physics. You know, everybody expected me to do the engineering job during my placement, but I didn't do it just because I was studying engineering. I went into something that I thought, this is exciting. I'd like to know more about this. So I did something different. So same thing with going out on my own, doing Athena Space. I wanted to see what it's like. So I thought, okay, I'll try out on my own rather than staying in the same job. So think out of the box and see what you can do. And most importantly, do something you enjoy. It is so important. Try not to settle for anything. Find what it is that you like. Think to yourself, and it could be more than one thing. That's okay. Find what you like and try to do those things. And if you take nothing else from this presentation, take this, reach for the stars, and you will land somewhere. And do it when you reach for the stars. Do it to the best of your personal ability. So I hope you enjoyed this talk, and I hope that I was able to inspire you a little bit. And I hope that you saw the opportunities you had in space. Thank you.